Okay, with this next problem, we have a pattern. Shapes constructed with toothpicks. So figure 1, figure 2, and figure 3 are all just kind of like, new models of the same thing following a pattern. So the easiest way of solving this is to maybe make a table. And we can see that this is the first term, the second term, and the third term of our table. So term 1, or the first step of this, has 3 toothpicks, and we're going to count. The second term, or the second step, has 7 total toothpicks. And the third term, let's count them up, or the third step, if you want to call it that, is going to have, looks like 11. Okay, so we count up the toothpicks and we have a table. Now what we're going to do is use the numbers in the table and see which of the expressions down below, you see 4 of them there, fits every one of the steps of the equation. So let me make a little room here. Excuse me. What we're going to do is we're going to plug the numbers in from the table into the expression, keeping in mind that every single one of the steps has to match the expression. So if you take a look at the first one, if I put 1 in for n, 3 times 1 equals 3, that's good. But when I substitute 2 in for n, 3 times 2 is 6, that's not equal to 7. So 3n can't be the correct expression for this. And we're just going to do the same thing for the others. So now we start with b. The expression is n plus 6. So we're going to substitute 1 in for n. Since 1 plus 6 equals 7, and that's not equal to 3, this is obviously not going to be our expression that matches up with the table or the toothpicks. So let's move on to 2n minus 1. Again, we plug the numbers in. So we put 1 in for 2, or for n. So 2 times 1 minus 1 gives me 2 minus 1, which is 1. And again, that's not equal to 3. So as long as it doesn't match any of these, we know that that's not going to be the correct expression. So it has to be letter D. But again, being a good student, we always take the time to check and make sure, just in case we made a mistake somewhere along the way. So let's put the numbers in for n, for 4n minus 1. So 4 times 1 equals 4. 4 minus 1 is 3. That checks. That's good. Now plug in 2. 4 times 2 is 8. 8 minus 1 is 7. Again, that checks. That's good. Now we put the 3 in. 4 times 3 is 12. 12 minus 1 is 11. So since it works out on all 3 of the terms, our answer is going to be letter D, 4n minus 1.